Good morning, good afternoon, and good evening from wherever you might be joining us from. We're really pleased to see a large global audience dialing into our webinar today. My name's Alastair Scott Farris. I'm the Chief Commercial Officer for VROC. And today I'm really pleased to introduce Juarez Lowe, our CEO from our Asia business, along with the COO, Ake Long. We're really excited at VROC globally at the moment, whilst there are many challenges, and we certainly hope we find you safe and well given these unprecedented challenges that we're seeing globally. But there are a lot of positives out of the different operational challenges that we've continued to see in our business that seem to be driven by these new challenges, both economically and socially, we're seeing. So we've got many clients contacting us at the moment around how they can look to view their assets remotely and also predict failures before they occur. But like with all journeys, they start with the first steps, and that's what the webinar today is put together about. So without further ado, I'd like to introduce Juarez, if you can take over from here. And please, any questions, just put them on the chat section of the webinar, and the team will respond to you accordingly. And I think Juarez will have 5 to 10 minutes to respond to a couple of those key questions at the end of the presentation. So Juarez, thank you very much.
Alastair, thank you very much for that introduction. Without any further ado, I'd like to start presentation. So again, good morning, good afternoon, good evening, wherever you are around the world, whether you're on a platform or whether you're working from home. This webinar came about because a lot of people came to us and they said, we would like to start a digital journey. We would like to go somewhere. And a lot of times the CEO says, we must go digital. But when it goes down to the operational team, they really wanted to have a blueprint in how to go digital. So this webinar came about as a result of that, many discussions we had from all over the world. So what we're going to do over today is we're going to look at we're going to give a little introduction to VROC, who we are, what we do. Why go digital now? How do you start? And what are the problems for AI? What's the data that you need to look at things? How do you quantify the problem statement and then starting a proof of concept? And we'd like to leave about 5 or 10 minutes at the end of this for Q&A. As Alastair mentioned, if you have any questions on the right-hand side, there's a chat button. You can key in any questions that you have as we go along, and they'll either respond to you privately or publicly or save it for the end. And we'll answer them. Who is VROC? VROC started about 5 or 6 years ago as a pet project. What we discovered is a lot of people are looking at all the data generated from your industrial equipment, and they weren't really sure what to do with that data and how to come up with insights. So VROC originally started on the bottom right. You can see it started in Australia, moved along Southeast Asia, Middle East, Nigeria, as well as the North Sea. So what are the key things which distinguish VROC from other operations is that we've saved clients more than $100 million. Whether we've churned lots of data, if we don't save clients money at the end of the day, that's the most important thing that people are looking for, especially in this depressed oil price with COVID-19. So what do? We look at 3 things which help people go on their digital journey. Number 1, we take the data that you give and we pump it into VROC Predict, where we will look at time to failure of key assets. So how long it takes for your assets to fail and what is the root cause of that future failure. The other thing that we do is we help you with production optimization, and we also have a team to help consult and say, what are the sensors or data that you'll need to start on your digital journey, depending on where we are with our journey. So this is quite an interesting slide. Prior to COVID-19, I would tell you that the chief engineer is able to look at his dashboard and tell you the compressor will trip in 7.2 days from the beach in Bali, and he will call the guy in the North Sea. In this era of COVID-19, the chief engineer is probably more likely to be at home and make the call to the guy offshore. But at the end of the day, the VROC end product is a dashboard which we can tell when the equipment will fail, why it will fail, and what are the actions that you'll need to do. A lot of times the dashboard gives you insights into that. Now, a question a lot of people say is, why go digital now? I have so many other things to do. So this is something that is a very frequently asked question. So we've actually devoted a couple of slides to it. as you'll see, AI is the way of the future. $13 trillion worth of value is quite a lot. And also both EY and McKinsey say there's a tremendous future in AI and a transformative effect. But in essence, what's happened right now with COVID-19 and the current oil price, unplanned deferment or unplanned downtime in oil and gas is one of the most expensive things. It's even more expensive in this era. There has been blanket cost cutting, OPEX reduction. So as a result, spare parts and people will be scarcer. So one of the effects of COVID-19 is the fewer flights. Therefore, it will take longer to transport anything from Houston to Kerteh or wherever it may be, or to Balikpapan. So the longer lead time for parts and equipment to travel across the globe. There is also restricted movement. When I initially did this slide, it was only 1/4 of the world which is under restricted movement. Now, up to half the world or even more is under some form of restricted movement. So in the new normal, it takes even longer to transport a seasoned engineer from Houston to Balikpapan or wherever it may be. So given all that, now is the time to go to digital, because you need to be able to predict when your key equipment will go down and why it will go down, so you can predict it and plan for the future. Now, the benefits of going digital, I think everyone's talked about them. When we worked with a client, one of our clients had 14% unplanned deferment. After going digital, that went down to 6% unplanned deferment. So production, as a result, can go up. Asset reliability and life cycle goes up. When things don't blow up, the safety obviously improves. Now, an interesting thing we found about digital is a lot of times when engineers do analysis, they do analysis on a certain part of the platform and exclude everything else. But in AI, when you use an AI engine to look at it, it can look at the entire asset infrastructure, therefore finds seemingly unrelated factors causing failure across the asset. So it can analyze the total asset, which could be billions or trillions of data points. Digital also supports remote working. We've talked to some of our clients. Prior to this, they rarely use Microsoft Teams. Now all of them do Teams meetings. And when digital is in place and running well, at the end of the day, profits increase. Now, great question. This is part of our webinar. How do you start? So the first most important thing is not to do digitalization because it's nice, because it's a fun thing to do. You've got to build a solid business case for digitalization. So some people say, look, I want to do a digital test case, and I want to test something which has already been solved. In that case, there's no point in doing that to start your digitalization journey. You might as well work on something that hasn't been solved rather than just testing the AI. So building a solid business case, what is the exact nature of the problem that you want to address or to solve? Now, when you begin your journey, you need to ensure there's a project driver. Normally, this is the field manager of the asset, the production manager. There is also a process expert who might be an engineer or a team of engineers who understand the P&ID and the end-to-end process. There is also going to be an IT or ICT person who will be able to ensure data flows smoothly, seamlessly, and through the corporate firewalls that we have. Based on this, you will then need to select your first problem statement for your proof of concept. Now, when we look at this, we need to discover what are the ideal problems for AI. And this brings me back to one of the questions that I've got. Now, I tend to get this question a lot, wherever it is around the world. People will ask me, Juarez, I'd like to look at this particular piece of equipment, this underwater submersible pump. It has no data whatsoever coming from it. There's no data anywhere. Can your AI do it? And that is not the capability of AI. AI works where there is data. So we have huge capability with trillions of data points. Now, the interesting thing with AI is when you look at the total asset, it might say something in the wellhead could be affecting your surface production. So it looks for correlation among the trillions or billions of data points. And the interesting thing about AI, at least the AI that VROC does, is it looks at the root causes of future potential failures. So it's taken on a predictive element. Typical use cases for AIs could be future failure of equipment. So traditional operations and maintenance looks at routinely maintaining it every 10,000 hours. But in reality, when a big wave hits a platform or things change or wells dry up, things will change. Therefore, it might not be routine. You might not need to do it every 10,000 hours. You might need it 11,000 or 12,000, or it might fail earlier. So it might be unplanned equipment failure that might have been frequently happening. So this is what we call the bad actor issue. So over here, the VROC predict platform is useful to do this because it can look at all the root causes of the future failure, looking at the total asset picture. We've also done a case in distribution power flow monitoring. So we look at how to predict the network stability and advise power on how to manage network stability. We're also able to do testing of underwater, underground cables using artificial intelligence. In the case of an offshore platform on the North Sea, we were also able to look at downhole pump failure and explain why they failed and predicted them before they happen. So the uses of AI generally are where there is data supporting it. So this comes into the data that is required for this. Now, what we generally find, if you take the data from a pie type or data historian, that's good. We take sensor data, all sorts of data, and all that goes into a data center, gets crunched out and gives your on-site or off-site guys a cloud where they can look at the predictive capability of the equipment. Now, what are the limitations of AI? People often ask this to me. A lot of times AI might, in terms of image recognition, isn't quite there. A friend of mine took a picture of a kangaroo and the Huawei AI called it a dog. So we still have some limitations in terms of visual AI. One of the biggest problems is where there's no data. Where there's no data, the artificial intelligence is unable to do anything or do any prediction. There's also a limitation where the data is incorrect. And if you feed in bad data, you get garbage in and garbage out. Now, in some cases where we work with a client, we found there was a machine serial number which kept on giving us fluctuating values. It's obviously not a machine serial number, but a sensor instead. There was another case where they asked us to look at pipe corrosion, and the pipe corrosion numbers moved from 14 mm to 6 mm to 8 mm within the space of a year, which is obviously not correct. So all these are situations where the artificial intelligence will not be able to come up with correct conclusions. Now, just wanted to share this slide with you. This is due to my daughter. I have a lovely daughter who doesn't log off to her account and watches everything on Netflix. Now, no one blames the Netflix algorithm. Netflix is $1 billion company. In fact, with this COVID-19, I think Netflix is even bigger. But these are my top 3 recommendations on Netflix. Now, Boss Baby, SpongeBob SquarePants, and The Christmas Prince, The Royal Wedding. This is based on bad data. So the old IT saying garbage in, garbage out. There's no problem with the AI or the algorithm, but it's a problem with bad data. So right now, after this, my daughter immediately has been made to log off my account. So thank God, Fast and Furious and other things have come up as my recommendations on Netflix, and I haven't seen Boss Baby or SpongeBob SquarePants since then. But it's a very simple example to understand that we need correct data to make correct conclusions. Now, one of the other things that we move on is quantification of the problem statement. Now, a lot of times engineers come to me, they want to solve this problem. The company might have $1 billion turnover, and I ask how much is a problem worth, and they say the problem's worth about $2,000. Now, when the problem's worth $2,000, there is an issue. Sometimes people are not really that keen to devote a lot of resources. The field manager might not tell the engineer, please go look at that. I want you to solve that. So you need to find a problem statement that is worth enough money so people look up and want to solve it. So this is a slide that we came up with, which we think is quite useful. Again, you'll be getting a recording of this. What is the thing that you want to look at for your problem statement, and how do you quantify? If it's a bad actor, for the AI to understand it and look at it better, it needs to have had a minimum of 2 failures in the last 12 or 24 months. So a piece of equipment that has been consistently failing is something that we want to look at. And another question that we ask, whose KPI does this piece of equipment affect? Now, if this piece of equipment affects the field manager, the assets KPI, that's good. If it doesn't affect the field manager, then it's less likely to get focus and priority. Now, another case that we also look at is what is the cost of this failure? If it's a compressor that's failing, what is the damage and the actual cost of the compressor failure? So maybe if a platform is producing 20,000 barrels a day, then we might now need to say, okay, every time the compressor fails, it's down for 5 days. That's 100,000 barrels a day. It may have emergency costs. For example, when the compressor goes down for 2 months, you may need to fly in a backup compressor to go there, or you need to move in a backup compressor. You may also have knock-on effects. In one of the refineries that we were talking to, they actually had a discussion, and if the refinery was down for 12 hours, all the offshore platforms had to stop production. Now that is quite a lot of knock-on effect of stopping 5 offshore platforms having to stop production due to the refinery. So it's very important to quantify and to write down what is the actual cost of all these things. Because when the costs, a lot of times talking to oil and gas, the costs generally tend to run not in the hundreds of thousands of dollars, but when you look at all the knock-on emergency costs, loss of production, knock-on effects, the costs often run in millions of dollars. Now, when you have quantified that cost, you will normally get the dedication of the operations, the field manager, to ensure that the project is prioritized. What you want the field manager to say is that this engineer is now dedicated to look at that particular problem statement, and I want him or her to be available to look at it, to get the data together, to check the data is accurate, to pass the data on to the AI. Now, the other thing that we also look at is, are we just taking that data from that particular piece of equipment, or are we taking it from the entire asset? I've got a case study that I'll run through with you guys where we actually found that there was a failure in a filter. And that failure in a filter was actually due to something else happening prior to that process. So sometimes VROC has found that maybe there's a failure in a compressor, but it might be due to the vibration of the turbine next to that particular compressor. So the reason why a lot of engineers can't find this is because when you look at one compressor, you might have 5,000 data points per compressor, which generate about 500,000, 1 million data points a year. But when you take the data from the whole asset, you might have 50 billion data points in 1 year. And there's no way engineers as humans would have the bandwidth to look at all that data. So moving on to start off on the proof of concept. So how do we start the proof of concept? So let's move on to this particular slide. So the questions to ask when starting a proof of concept are, can you deploy remotely? This is an interesting thing to share with you. When COVID-19 happened, the VROC global team got together and we had a scrum, a huddle, and we said, actually, can we deploy our solution remotely? Given the fact that our solution is data analytics, we found, interestingly enough, we could deploy the VROC solution is actually one of the COVID-19 compliant solutions. So we can actually deploy remotely. So the questions you'll ask, can you deploy remotely? Now, we also talk about agile AI. Now, one of the good things about looking at the entire asset infrastructure is sometimes you might find that you might just be looking at the compressor problem, but it might actually be related to the removal of a wellhead filter. So the AI will be able to look at that, and then we might be able to bring in the AI, the engineer in terms of the wellhead filter. So one of the things about the VROC AI, when we take the total data, you can actually look at multiple problem statements within that whole asset infrastructure. So one of the things that you may also look at are you looking at 1 or 2 limited problem statements, or is it easy to just click and then make a few multiple models within or multiple problems within that particular asset. Another question people ask, is our solution industry specific? And one of the other questions which come up is the data sovereign? In some cases in Indonesia, they say the data can't leave the country. In other cases, they can say some parts of the data can leave as long as it's destroyed. In other cases, they will ask to make sure that the servers are secure. But an interesting fact is that one of the companies which told us we are very, very concerned about our data leaving the country, that company is a user of Microsoft Office. So when you actually save everything on Microsoft Office, in general, you will save your Word document to the cloud. And that cloud may not be in your home country for sure. So right now, we're finding that a lot of oil and gas companies in particular are also understanding that a lot of the data is normally in a cloud somewhere, and it could be all over the world. So this is one example I'd like to share with you guys on, which probably highlights what happens when you use an artificial intelligence solution. So this is a mineral processing refinery. Now they had 170,000 sensors. The issue was premature filter clogging. Now this had happened for 20 years. So the filter has a lifespan of X months, and the filter kept on getting clogged prematurely. Now this problem had been occurring for 2 decades. Now there were 50 buildings over here. So what they did with VROC is they chucked in 12 months of process and equipment data, about 40 over billion data points. And then after that, they asked the VROC AI, why is the filter getting clogged? Now with 170,000 sensors, that's 44 billion data points just processed by the AI. As we know, using traditional Excel sheets, we would be unable to look at that. Now, in this case, the filter was getting clogged in building 35. Now, traditionally, engineers would just look at the problem in building 35. I mean, one of the things some engineers shared with me is they say sometimes we just look at things in isolation because the guys in charge of building 35 might not even talk to the guys in building 25. They might not have lunch together. Now, with human limitations, we would just look at building 35. With the VROC AI, we were able to take all those 44 billion data points and put it through the VROC AI. And in the space of about 45 to 90 minutes, the AI came up with a conclusion. And it said the issue of the premature clogging of the filter in building 35 was actually related to the rock crusher in building 25, which is going to be my next slide over here. So the process, or the SOP, is that the rock crusher would crush the rocks. Each time before the rocks got crushed, caustic soda would get added. Now, if the rock was not crushed to the correct size, it would go through the process again, and then caustic soda would be added. So if the rock crusher wasn't doing its job correctly, the rocks would get sprayed with caustic soda 8 times. Now, we later found through the AI identified the filter blockage was due to increased levels of caustic soda because it was getting sprayed 8 times. So it was designed to be sprayed one or two times through the process. So this is some examples of AI finding seemingly unrelated factors causing failure in different buildings. So another example that we looked at, I'll just run through this very quickly, is a newly commissioned FPSO with 250,000 sensors. These sensors produce too much data for the reliability engineers to understand using the existing techniques, which are using Excel spreadsheets. So they were looking at unplanned downtime for critical assets, which were the pumps. So VROC looked at the pumps and identified degradation in the performance of mechanical seals in the pumps before it actually occurred. So over here, in a relatively new piece of equipment, VROC was able to predict degradation and failure before it happened, which would have resulted in catastrophic failure or downtime, which resulted to a $2 million saving in 3 months. So these are other examples of how using your digital solution to predict failure before it happens, therefore saving a lot of money. So I've probably spent about 24 minutes based on my watch looking at at all this. I thought I'd put it up to Q&As. Al, have you got any questions that you'd like to share? Hello? Okay, I'm just going to have a look at some of the questions which have come up. Okay, I have one question over here is, how does the VROC filter or identify the bad data to avoid incorrect predictions? One of the things the VROC AI comes up with is we come up with a number between 0 and 100 to say how certain we are of the prediction. If the prediction number is low, it normally has two possibilities. One is that we don't have enough data and there are not enough sensors. In the case of some cranes that we looked at in Singapore, we found out that we were unable to predict the load bearing failure. And in that case, we said, our PNID guys looked at it and we said we needed to put a vibration sensor next to the load bearing. In other cases, we found out the data was inaccurate. That was why we got a low degree of certainty. Generally, if we get any degree of certainty above 60%, then we're normally doing quite all right. If we get a degree of certainty between 10 and 20%, normally it means there's not enough data of the subsection. So again, the AI is limited. It is not superhuman, and it doesn't have a crystal ball able to tell everything. The engineers will need to look at it and say we either need more sensors or we need to check on the correctness of the data. So in one case, they looked at asking us to predict corrosion in the pumps, and we just opened the first few data sets, which showed us the pumps, the corrosion in the pipes was, the pipe thickness was going up from 14 mm, 6 mm, 12 mm, all within the space of 6 or 7 months. So in that case, we understood that the data was incorrect. In another case, they asked me to look at a particular navy in Southeast Asia, and they said there was a visual inspection done on the engines. And when I did a walkabout, I found that there was oil, which had crusted up near the engines. But the guy had signed saying that all the visual inspections had been done daily. So in that case, you know, obviously that data is probably incorrect. Al, any questions that have come that you'd like me to look at? I can't hear you, Al. Is your mic on? Okay. I'm just going to put another question. I've got a question there asking me, how do you link the massive census data to the VROC AI? Most of the time, in some cases, some people don't have the data all linked together. Some of the clients, probably about 30 or 40%, and oil and gas especially, if they have a PI historian, that links all the data together. And the data is then transmitted onshore. So past data could be taken out by a hard drive, and then after that, the data is just sent out depending on how often the client wants, in 15-minute intervals, in 1-minute interval, in hourly intervals. But I hope that's answered that question. There's another question that I got. Can you justify your system during these trying times? There's a very interesting slide on that I just wanted to share. It's why go digital now? So can you justify it during these trying times? Well, when you look at the fact is, if you're going to get someone to come along through the system, and your old SOP is, you know what, the system goes down, we'll call the engineer over, we'll get the engineer offshore, onshore to go and have a look at the piece of equipment, we'll fly the engineer offshore. You can't do that now. You might have a 14-day quarantine, especially if it's in East Malaysia, before your engineer can move even onshore to offshore. So in that case, that's something which would take a lot more time. Even your movement of parts. I went to KLIA about a month and a half ago to drop someone off, and I found all the planes in AirAsia and Malaysia Airlines were grounded. And I think you've got the same in Garuda, Qantas, British Airways. A lot of the Etihad, a lot of the airlines are all grounded. So transporting parts is no longer something quite easy to do. Air freight of parts doesn't happen so easily. So can you justify it? If your cost of downtime is higher, absolutely. If your time taken to repair your asset is even longer, there is an even greater need now with fewer people on the platform, the longer time in moving personnel and parts. There is an even greater need now more than ever to go digital. All right, just checking if there are any other questions. One of the people asked, what types of sensors does VROC use? In the cases of oil and gas pieces of equipment, generally we found we've not needed to put a single additional sensor there. Most of the time we take the data from the existing process, wind, water, temperature, all that data goes into the VROC artificial intelligence engine and we read it. So we read all sorts of data. So as long as the data is exported to CSV or Excel format, VROC can read that data and it will look for correlations. So the difference between VROC, AI or any AI engine is that we can look at all sorts of data and look for correlation, whereas human beings would have limitation looking at 500 million data points. Now VROC can also look into the binary data. For example, the on-off switches of electrical switches, the on-off of valves. Given that we can look at the on-off of valves or switches, we can actually calculate the microseconds between the on-offs and see if it's changing, and therefore use that to calculate time to failure. So one last question that I'll take, I think we're only supposed to be on this for about half an hour, is people ask me, when there's a prediction, how the results communicated, the client actually opens up their own dashboard every day. So the difference between VROC and other pieces of equipment is a dashboard's a blank page. So what you'll find is a field manager might have a dashboard with 3 or 4 pieces of critical equipment, and you're going to find that other people would have, the well engineer would have a dashboard on all the wells, predicting the time to failure on the wells based on smart wells. The compressor engineer would have data on the compressors, or the process engineer would have data on critical processes, looking at moisture levels or EDQ in the future, and the turbine or generator engineer would have his own dashboard predicting that data. All right, I think we said we were going to be on for about half an hour. I think I'll just pass it on. Alistair? Alistair, are you there?
I am. Thank you, Juarez. I think that was fantastic. There's still some more questions coming through. So just to reiterate to everyone who's joined us that if we didn't get a chance to respond to your question during the webinar, we will respond offline. And we welcome any further questions or engagement post that. You can always get in touch with us through the website if needed. But fantastic job, Juarez, and I hope everyone's enjoyed it. Thank you so much.
Thank you very much, everyone. Please stay safe and have a great day. By the way, that's my contact details if you have further questions, or just leave them in the chat, and we'll be happy to address them later. Also, if there are any particular webinars that you'd like to look at in depth, or you'd like a further in-depth one-on-one discussion or exploration on what you want to do with the system, please post it in this chat, and we'll be quite happy to set up further appointments. Thank you very much, everyone. Have a great day.